yeah, Piotr is going to give us a talk about microdispensing and the company's inkjet printing technology and how it relates to our industry. So you have the floor and you can share your screen, I hope. Yeah, it comes up.
Exactly. So thank you very much. Okay, so I will be talking about microdispensing, and in particular microdispensing for packaging. And I'm coming from a company called XTPL. We are a Polish company, but we are operating worldwide. So we have a number of distributors. We have quite an interdisciplinary team of around 90 people, a lot of them with PhD degrees in physics, electronics, material science, chemistry. So this research component is quite important for us. And we also take IP seriously. So we have now 40 granted patents on the technology I will show you in a moment. So when you think about printed electronics, the landscape is quite wide. So I will be talking today about microdispensing, so about the top left corner of this plot. So printing micrometer size features, and in particular printing these features using a very high viscosity inks. And the idea for a microdispensing technology we're using is as follows. So we have a printing nozzle with the micrometer size opening, and the whole process is governed by pressure. So we have a precise pressure control system. We're able to precisely position the printing nozzle with respect to the substrate and then dispense this very high viscosity material using this very narrow nozzle. And on the right-hand side, you can see a kind of a table of content for my talk. So when thinking about integration, you can think about a couple of different approaches. So you can think about chip interconnections. You can think about printing interconnections on the edges. You can think about deposition of micro bumps or filling micro vias. So these are a kind of approaches you can use with our technology. So this technology is actually implemented in the devices. So one of the possibilities is the laboratory printer, and the other is the one you can see on this slide. So a dispensing system that can be implemented on a production line. So I hope you can see the movies, and you can see that we can dispense pretty arbitrary shapes. So whatever is needed for your architecture, you can load it to the system and print it. So there are no problems with making turn routes or printing whatever is needed for a certain architecture. And then to demonstrate this printing flexibility, we just printed this message. So we'd like this technology to revolutionize the yield management and the heterogeneous integration. And you can see that indeed there is no problem in printed this arbitrary shapes or letters in this case. And the line width for the letters is 5 micrometers here. So when you think about integration, the first thing comes to mind is the idea of printing on steps. So usually you would like to integrate the different components, and this printing on step is necessary in this case. So you can see different connections, different examples of printing on steps. So you can see a connection on a microchip, and this is the microchip with the height of 350 micrometers and the line width of 10 micrometers. So you can see that the line width is much smaller than the step height. And similarly, you can see this type of connection printed on a rough surface and also on a step with a height of 1 millimeter. And thinking about MicroLEDs, of course, this is quite an obvious choice to make a metallization scheme in MicroLEDs. And you can see an example on the right-hand side. So there is MicroLED chip with a step height of 150 micrometers and then we make a connection using a 10 micrometer wide